Hello, welcome to a new episode of Data in the Hallway. My name is Ray Paik, Community Manager for TiDB. Honored to be joined by Andy Pavlo, Professor at Carnegie Mellon University. Hi, Andy, how are you?
Doing great. You should also mention your distinguished CMU alumni.
Yeah, I am. I have a very non-technical degree from Carnegie Mellon, but yeah, we won't get into that too much, but it might come out. So,
Yes.
yeah, so I mean, we actually had a chance to meet. I guess now it's almost about a month ago when you came to speak at our Scale Summit, and I think like unfortunately I had other like a booth duty, so I couldn't sit through your sessions. But we'll post a video on the podcast description so people can watch the talk. But I think the topic was using LLMs for like a database tuning. If I'm mischaracterizing it, please let me know. But so obviously AI is fascinating for a lot of aspects of our lives, but I mean database tuning or optimization is it was what a lot of people are talking about. But I so I mean so I mean, feel free to like introduce yourself and talk about like your interesting research areas. I'll post a link to the computer science department webpage so people can look at your classes and all that too. But yeah, tell us a little bit about yourself and what you're looking at these days.
Absolutely. Yes. So my official title, I'm an associate professor with indefinite tenure in the computer science department at Carnegie Mellon University. My main research area is database systems. It's like, other than like my wife and my kids, the only thing I love in life, because everything's a database problem at the end of the day. So my research has been focusing on how to build basically new database system architectures and how to use AI or machine learning techniques to automate the optimization of systems. And so we've sort of had these two tracks for the last 10 years or so at CMU where we've looked at how can we use AI to optimize sort of existing systems, and then how would you build a new database system where you knew it was going to be controlled by AI and you can make certain design decisions from the ground up, like as you design the architecture. So the talk that I gave for you guys has been really a summary or survey of the last 50 years in this space of database optimization or automation of database optimization. Right? So think of things like picking knobs that control like the behavior of the data system for tables, for indexes, for anything else, anything they expose to a human operator. Classic physical design problems like picking indexes, picking sharding keys, materialize view, and so forth. And then we've also been looking at how to optimize the query plan hints or the query knob so we can control the behavior of queries when they show up in the system. So the our more recent work we've been looking at is obviously using LLMs, but we're not using them as the how does this is the thing that decides how to optimize the system or like what to specifically like what index you should add and so forth. We've been looking at using techniques from LLMs and as well as LLMs themselves to look at how to tune holistically all aspects of the database system at the same time. And then we can use LLMs to actually do knowledge transfer so that if we have databases we've tuned in the past on different hardware, different versions of the system, different workloads, we can transfer that information, that transfer those experiences to new databases so we don't have to go through the full training process. So the what's different from what we're doing now than what we've done, at least my own career from the last 15 years, but even prior to that, going back to the 1970s, is that instead of building these sort of singular algorithms or tools that can tune just one aspect of the data system, like here's the tool that tunes indexes, here's the tool that tunes knobs, our new work is looking at how to optimize this problem holistically all at once, because that's really the way to get the true global optimal configuration you want for your system.
Cool, cool. Yeah, I encourage people to take a look at the faculty page that I'm gonna post on LinkedIn. And I mean the other and then you know sort of add on to like your research area. Like I like the like I think there was an area for projects. And then there
Mhm.
are like a project links that people can take a look at. And one that caught my attention, I didn't like I may have heard from Sunny Baines, my colleague, about this. You have a like a page called like database of databases. So you
Yes.
have things like a ranking. So like what? So how do you compile the information for that page, and what was the motivation for that? Was it to sort of help your students and other people to get a better view of the different databases, or like,
Yeah, so the website is that it's database of databases, an encyclopedia of databases.
yeah,
The URL we were going to go db2.io, and of course, obviously
uh,
IBM would sue us. We couldn't do that, so we did
right,
db.io, right?
right,
Um, I'm serious when I say I love databases. In any other profession, this would be seen as a mental defect. But because I'm a professor, right? My
yeah,
obsessiveness is considered like, oh, he's eccentric. He really knows his stuff. So the database of databases was I built it for myself because I want to start keeping track of all the various database systems that are out there in the world and keep track of like what are their how are they actually implemented? Like what features are they supporting? What's what programming language are they written in? What's the query interface they support? Are they shared nothing, shared disk? Like try to keep track of all these things because it was mostly to satiate my desire just to keep track of databases. But then I also found it to be a useful teaching tool as well in my courses because students would often ask, as we're presenting material, like, okay, great, like you're telling me something that's in the textbook, but what systems actually implement this? What systems actually implement two-phase locking versus multi-version code control? And so that was a way for me to start categorizing them and keeping track of what was out there. Because the cool thing about databases or databases as a field, it's, as a researcher, not only am I competing against competing is not the right word, but you know what I mean. Like, not only am I by putting out my work and comparing against other researchers at other top universities, but there's also, the large companies like the Microsofts, the Googles, the Amazons, where they're putting out a bunch of database systems as well. And then there's a huge number of startups as well that are all building, new interesting database systems. So it's like this really active space, and it's been that way. I mean, really since the dawn of databases as an industry to the late 70s, early 80s. And so I wanted a way to sort of keep track of like all these things that are out there and understand how they're different, how they're the same, and look for patterns and trends. Um, so the way I find database systems is a combination of things. Obviously, there's the classic ones, like the well-known ones everyone knows, the Postgres, MySQLs, the Oracles, and of course, there's the bigger startups like TiDB and PingCAP. The people of that sort of same generation.
mm,
Um, but then it's a combination of I find them through posts on Hacker News. Like even though they
mm,
don't make the homepage, if you just search every so often to see just the keyword database, you'll see people posting, "Hey, here's my new startup. We have a new database," or someone's got an interesting GitHub project.
mm,
And I take a look at them, see whether they're actually real or not. Like um, sometimes some of the databases out of China, it's unclear what they actually are. And obviously, I ask my students to help me translate things. So sometimes they're fake, sometimes they're real. But like it's just like well, in addition to the Hacker News post, and then people email me also too, say, "Hey, look, I have a new startup. Here's my new database. Or I have a new hobby project. Here's my database system." And so,
mm.
as long as you got a logo and it looks real, and it's got a name, we'll add it to the website. But we can
Okay,
categorize it. We can categorize like, is this a commercial product? Is it like a hobby project? Or is it
right,
a parody project? Right.
yeah, yeah. I mean, there are. I mean, not necessarily they're competing with you. There are other sites that list like various different databases. Like some people even rank them and all that. But what's amazing is, I'm not the type of person who pays attention to how they rank stuff or anything. But the just I mean, there are just so many databases out there. Like it's like you kind of at least for me, like I can kind of rattle off maybe 15 of them. Then you realize there are a lot of different types of databases, and there's so many databases that I don't even know about that have like huge following. Like if you go look at their GitHub repo and Hacker News and other forums, right? So it's
Yes.
I mean, I think a lot of people share the maybe not as passionate as you, but there are definitely still a lot of interest in database, which some people might not necessarily find it very interesting in CS. But
And so
yeah,
when you look at other disciplines and systems,
yeah,
for example, like operating systems, right? Like there's not many startups that I can think of that they're going to try to build a brand new operating system to replace Linux. It's mostly either academic projects, which there's not very many of them even, or small hobby projects, or someone's going like, I'm going to learn Rust, let me write an operating system, right? When database systems, it's really fascinating because it's like everyone thinks they can do it better than everyone else. Uh, and that's why you end up with all these variations and all these, and there's obviously a lot of money in it, so everyone's always trying to build something new. And I personally wonder though, how long is that's going to last? Like if I chart like the number of new systems, data systems that have been sort of released in the last 10 years, this definitely has accelerated. Um, but eventually you can see that maybe there's going to be a convergence on like just Postgres being like a generic Linux that everyone uses, and then there's the specialized systems like TiDB and ClickHouse and all these other ones for other problems. But like, I mean, everybody has data nowadays, and everything's a data's problem. And the choice of system you would use in something like in one system over another for your particular application needs and workload, you can have a significant difference in performance and cost. Whereas like if I choose FreeBSD over Linux, I'm probably not going to see, order of magnitude difference in performance. So there's more activity because it's closer to the application than maybe the OS and other levels, other parts of the system. And like I said, at the end of the day, everyone feels like they want to build a new data system to replace whatever they're already using. And so people do it. You muted.
Sorry about that. Like
It's
I
okay.
was talking with the mute button on. Apologies. Yeah, I've been away. I had been away from like an analytics space for a while, and then when I first came back, like because I was thinking how interesting would this be, and it turns out it's very fascinating. I mean, a lot of startups and a lot of a lot of different diverse communities. So yeah, it's been pretty fun.
But when I
Yeah,
say when you,
yeah,
when you look at like the trends in
yeah.
computing,
Mhm,
and application development, the last, I mean, going back to the 70s, every
mhm,
time there's a major generational change in either the hardware or the type of applications people want to build, right?
mhm,
There's always going to be new database systems people build to reflect that change, right? When
mhm,
object-oriented programming was a big thing, I mean, it's still a big thing, but when it became a sort of
mhm,
novel thing in the late 80s, early 90s, there was a bunch of databases that were object-oriented databases. When
mhm.
XML became this big thing, there was a bunch of XML databases, right? Like there's always changes in trends. I mean, of course, the modern one now is all this AI stuff, and you see new
Mhm.
crop of vector databases come along that support RAG architectures or RAG systems,
Right.
and those kind of applications much better than maybe the existing ones at the time.
Mhm. Cool. Yeah. I mean, speaking of AI, I think we mentioned it a few times, and it wouldn't be a modern day podcast in 2025 without talking about AI at some point. Uh, Obviously, you know, you teach students. I mean, you've been doing that since you joined Carnegie Mellon. Uh, I mean, how has like because I mean, as a pretty old person now, I haven't written like a meaningful code in the past 10 years or so, but I really get jealous at looking at resources that students have nowadays for programming and writing code in general, like both hardware and software. And with AI, even more so. I mean, I think if you use it correctly or appropriately, I think it is an amazing tool. But how is this changing the way you teach students at CMU? Like,
Yeah, I mean, this is a big challenge,
yeah.
for everyone. Like, no one, to be honest, nobody knows the answer. Like, what does
Mm,
it mean to have a computer science degree going forward? And the best I can offer is like, if people say, I've had people ask me like, oh, should I encourage my kids to go into computer science? And the answer I would say, good, if they're passionate about it, then yes. Because at the end of the day, the fundamentals are what a computer science degree is about, right? It doesn't matter whether you're using an LLM to write stuff already from scratch. If you understand the core concepts and algorithms of what, not just in databases or any part about computers, that's what really matters because it allows you to then to decipher and determine and evaluate what these modern programming tools can are doing for you or attempting to do for you. I would say in my course, so I teach a upper level undergraduate master's level database course, sort of introduction to database systems, and then we also teach a advanced graduate level, PhD level, master's level uh, advanced topics or advanced database systems as well. So for the intro course this year, I straight up told the students at the beginning, like, use LLMs, use Cursor, use Anthropic, ChatGPT, whatever it is, help you do the projects. But you have to understand that like there's limitations of what these things can do. Um, and it probably is not going to be able to help you debug, complex problems with concurrency control issues and race conditions and things like that. And so if you're just trying to debug code that you didn't write and you don't understand what's going on, you're going to have a hard time. So I would say that for the intro classes at CMU, again, I don't teach them. I like, first year, second year course, we have amazing teaching faculty that know how to, bring in students, bring along students who you maybe don't have any programming experience prior to starting a CS degree at CMU. Like they do a very good job at like getting them up to speed on the fundamentals. And that for those courses, I do know that there is a larger emphasis on in-class assessment, quizzes and things like that, because you don't want people just vibe coding stuff in their dorm and then assume they know stuff and then they get destroyed later on when they take the more challenging courses. So again, in my course, I encourage them to use LLMs because it's like GDB, it's like any other tool now. It's what you should be using. And I will say anecdotally, things like Claude and ChatGPT, these things have gotten way better in the last year.
Hmm.
Like I think when ChatGPT sort of hit mainstream, 2 years ago, we tried throwing it at some of our programming projects, and it kind of again, it would put something out that if you didn't know what it was doing, it would think, oh, sure, all right. Sometimes it would compile, sometimes it wouldn't, but it definitely didn't solve the problems. Nowadays, it can do a fairly good job of just doing some of our projects automatically. I mean, with some finagling, of course, right? Um, and so our decision, what we've done is we've decided to actually make the projects harder this year.
Hmm.
And we told the students this again, like now
Right.
you have this amazing tool that can do a lot of the grunt work for you, but therefore we can push you a bit harder and make sure you really understand the fundamentals of what database systems are actually doing. I will say, so for the projects, it's hard to, again, we can't prove that it was written by a human versus like, LLM. The only antidote I would say that maybe you know, there may be some troubles on the horizon is that we in our first homework assignment this semester we ask them to write SQL queries. We give them like here's some sample data set and we tell them solve this question by producing this result, and they write the queries on for DuckDB. Um, and then on the midterm exam a few weeks ago, we did ask them a SQL question, and we warned them like you have to if you use LLMs to write the SQL, that's fine, but you still have to understand what SQL actually is and what it's actually doing.
Right.
And we had the lowest score on the midterm for the SQL questions than we've had in any previous year. Uh,
Wow.
which
Interesting.
which is
So,
not good, but
yeah.
like so
So
it's
was a question, I mean, not to get into like a too much detail, like was a question more like what is SQL statement doing, or is this correct? Or like what were the type of questions you were asking? Like,
yeah, it'd be like here's the example would be like write a query that produces a left outer join without
mhm,
using left outer join, and we then give them sample queries that like try to
right,
compute it. So one would be using window function, one would be using CTEs, one would be using sort of subqueries with a like a union all kind of thing.
right.
And if you don't like, and so the it's only an hour, 20-minute exam, so I can't ask them to like
Mhm.
do something too heavy. But like if you understand these constructs in SQL, then the answer is pretty obvious. Uh,
Okay.
but I think less than 10% got it right.
Okay. So it's
So
basically testing for understanding of the constructs.
yes,
Okay. So like so you need to be able to judge if cloud or something is generating code, like need to be able to judge whether this is doing the right thing or it's just
yes,
completely out in the woods. Okay.
yes.
Yeah, that makes sense. So
And so like
yeah.
so like you kind of see the writing on the wall in some ways. So like
Hmm.
all right, well that's just SQL. And
Hmm.
then having students come to my office hours or in the corresponding with other TAs, you you still get the sense that the students are still, at least the ones that are coming asking for help, are still writing the code themselves, which is good. And
Hmm.
again, maybe they had LLMs get them started on something, it's fine. But the rate in which these LLMs are really improving, it
Hmm.
may be to the point where like the projects are like you could just have just give almost the project website and it produces a working result. Like that future is coming, uh,
Hmm.
and nobody knows what to do about it. And it's because
Right.
it kind of becomes hard to scale larger classes if you have to start doing in-person assessment or handwritten code and analysis and things like that. We do that for some of the advanced classes, like in our operating systems course. That's only 30 students per semester, and there's one faculty that full time is like walking line by line, looking at the students' code, working with them to understand,
Hmm.
how to fix the problems they're having or how to grade them. For database class, we're teaching 150 kids per semester, and the
Right.
wait list is another 100, 200.
Yep.
So I just can't scale that sort of
Hmm.
hand holding.
Right, right. Yeah, I mean, it kind of reminds me, like, I mean, I as an undergrad, I was a math major, but I did take a lot of like a CS courses, and I don't think I was ever a good programmer. I mean, it was kind of amazing. Like, I would do better on tests sometimes versus on programming. So I either I was immature or like there was something in the brain that wasn't clicking when I was like writing code. But I mean, testing for like understanding of the concept and writing code, I think you're reminding me those things are sometimes very different. So
And
yeah.
there's the Alpha Evolve or the Open Evolve project as well. Like now you're just writing sort of specs of what you want, and then
Mhm.
the LM spits out the actual full-fledged implementation of the system as well. Like that's where things are going. Where
Mhm.
probably in the next 10 years we still need people to like debug things.
Mhm.
Um, but like you kind of see where the world's going with these things could be completely autonomously built, for a single node system or a service by itself. Sure, that's fine. The more distributed stuff gets more complex as well. But
Mhm.
I mean, I'm naive to think like the LMs wouldn't be able to get there, or not. If not LM, something
Right.
else.
Right. Right. Exactly. So we talked about like a teaching and working with students. Like, what challenges does it pose for like research? I mean, I'm like, I was at a listening to a presentation the other day, and then the talk was given by an attorney. And then
Hmm.
one of the questions she got was like, what happens to a code that was if you wrote a code or wrote did some programming with the help of LLM, like what happens to copyrights? And this is kind of a thorny issue. And then authorship is pretty sensitive topic in academia, like having
Yes.
being married to one. I can relate. So what challenges that pose for research in general? Like,
But so in research, it isn't about the code artifact at the end of the day. Like the all the time the again, in systems, you obviously write code, and to the extent we can make the code that we write useful for other people outside of just our research group, then the more the better. I'm happy to talk about some of the things working in that space as well. But like I said, the end of the day, it's the fundamentals and the ideas. That's what we're really, you're really focusing on. Like a PhD isn't a PhD in how to write code or like how to use a database system or even build one. A PhD is really about how to do research. And then obviously my students are learning how to do it in the context of database systems and that domain. So the fact that whether like the research code is written by a student versus an LM, from my perspective, I don't actually care. It's again
mhm,
the fundamentals, the bigger ideas are what really matters. And
right.
then can we then compare our ideas against other researchers and other things that are out there to see whether what we're proposing is
Mhm,
a better way or has what are the nuances of it. So that the code authorship less of an issue for me for this.
mhm,
And again, if anything, it just makes us better, right?
yeah.
But then this goes back into like what I was saying, but like the fundamentals matter, and I think you know there's going to be a pretty significant change in sort of the what computer science looks like over the next, again, 5, 10 years, where unfortunately a lot of I just foresee a lot of the code academy stuff that's sort of out there. I'm not trying to throw shade at JavaScript programmers, but like the people that's kind of maybe doing things that are more easily automatable, uh, like that, I think that'll have a major disruption. But the places that can teach can really rigorous, core computer science education. And again, I realize it sounds like I'm a shill because I'm at a school that sells computer science education. We're gonna be okay, right? I don't mean it like that, but it's like at the end of the day, these things are gonna be uh, these systems are just gonna be more and more complex, and
Mhm.
there's gonna be fewer people that understand them, and the fundamentals of what can ground you to then go beyond whatever the hot topic is for today, and really transcend that and evolve as the field evolves as well.
Right, right.
But
Yeah.
but like vibe coding changes a lot. Like you can vibe code stuff so easily now, and like for
Mhm.
one-off things, and you don't need to necessarily hire a bunch of programmers for that anymore.
Right, right. Yeah, I think like you mentioned it earlier, and when we're talking about like education, like it's I don't think we can all predict like whether it's for research or teaching, like what the true impact would be. I guess we'll find out in a few years, but it's definitely interesting times. So, and then I mean, you talked about like whether it's object programming or arrival of internet. I mean, there are certain disruptions over the past 30 years. I think we're in one of them. Like, we'll see how it goes. It'll be a interesting journey nonetheless. So
Absolutely, yes.
yeah, yeah, cool. And I'm sure you get this too as a parent, like we've had discussions with other parents. I mean, being in the Bay Area, people talk about this. Like, is CS education worth it? That's how we were raised. Like, like this is sort of no guarantees, but that's the path you need to be in. Like, you need to get this like a type of technical degree, and then you join companies that look like this, and then that sort of provides some sort of a pathway to stable livelihood. But uh, yeah, we'll see how that all that evolves. But I'm sure being at like an expensive universities like CMU and a lot of, I mean, university education is just expensive anyway. So people are
Yeah,
people
you
having
you
having
you could say
discussions, right?
senior's
Yeah,
expensive. Like
yeah, yeah,
we're not a state school, right? It's a private school. It's
no, right,
expensive.
yeah. So yeah, I mean, I you know like you said, I'm also an alum of Carnegie Mellon. I paid a lot of money to go to that school. It's even more ridiculous now. I mean, compared to
Yes,
when I got my degree. And was it worth it? I think it was, but I'm not being very objective, right? So
yes, of course, yes.
yeah, yeah. So cool. All right. Well, thank you so much. I think that's all the topics that I wanted to cover about your research areas, what you're doing, and how the AI is impacting education and research. I think we time for our closing trivia question that we ask all of our guests. I mean, Carnegie Mellon's is located in Pittsburgh, Pennsylvania, if people don't know. So I wanted to ask you, tell us something about Pittsburgh that a lot of people may not know about.
I'll give you two. I'll give you one about
Yeah,
Pittsburgh and one about Carnegie Mellon. How about that?
cool. Yeah, perfect. Yeah.
All right. So yeah, so Pittsburgh is spelled Pittsburgh.
Right.
There's an H at the end of Pittsburgh. Uh, there were, for a brief period from 1891 to 1911, the U.S. government decided they wanted to drop the H from Pittsburgh, and it's Pittsburgh without the H at the end for those 20 years or so.
Uh,
And then there was a large complaint from all the citizens of the city, and then it reversed back into Pittsburgh with the H. So there are
okay.
some rare spots in the city where you can see old signage, like in statues and stones. You'll see Pittsburgh without the H. Uh,
Really?
yes,
Oh,
because it has to do with like I think like Edinburgh has an H, but then
yeah.
like some other like Hamburg doesn't have an H. So it was
Hmm.
kind of like trying to go back to more of the Germanic roots, but then people were like, "Oh,
Okay.
keep it the Scottish way."
Oh, okay, cool. Well, there is a Pittsburgh without the H here in the Bay Area, so I don't know if
Yes,
a lot of people know that, but yeah. So,
yes. And then
cool.
for Carnegie Mellon, I think I mean obviously, I mean the history of Carnegie Mellon was it was Carnegie Institute of Technology, founded by Andrew Carnegie in the 1900. We're at our 125th anniversary since the founding, and then it merged with the Mellon Institute and became Carnegie Mellon in the 1960s. But I would say is we don't hold the record for the first computer science department in the United States, but the CMU CS department was founded in 1965. So we're off by 3 years. The youngest one or the oldest one is it was Purdue, and they were founded in 1962. So ours is old, but not
Right.
that old. And then we didn't have a undergraduate degree for, I think, until like the 1990s. So for 30 years, we only had a graduate program in computer science, and that's where all like the groundbreaking work in AI and robotics was done. And only
Right.
since the 90s we've added an undergraduate degree. And again, I'm biased, but I think it's one of the best in the world.
Wow, I did not know that. I didn't realize like undergraduate, like a bachelor's degrees weren't offered until like the 1990s. So it's
Yeah.
pretty recent. Like,
Yes.
wow,
So
wow.
for us to like be at sort of the level we're at and not and our
Yeah.
undergrad degree being much younger than a bunch of other places is very impressive.
Mhm. Cool. Awesome. Well, thanks for sharing those factoids. Neither one of those facts I knew. Like I spent 2 years in Pittsburgh. Thanks for sharing those. So
Yes, absolutely.
cool. All right. Well, thanks very much, Andy. And hopefully our paths will cross again.
Absolutely. Thanks.
All
Hit
right.
me up anytime.
Thank,
See ya.
thank you.